Hello and welcome to Dakota Press video tutorial on how to size overcurrent protection for the primary of a transformer. So I've got another video that kind of explains why we do the things we do here. So we're just going to jump into this. We've got this question here that says, what is the maximum allowable rating for an overcurrent protected device protecting the primary of 112.5 kVA? That's a big fella. Right, that's a big old transformer there, 112.5. It is a common size. It's a big one. It's a 480 volt to 20. It says 201. That's a mistake. It should say 208. We got a 208, 120 three-phase transformer. Okay, so the only way that we have 208, 120 is with a Y three-phase configuration. Right, we don't get that voltage combination with any other transformer unless it'd be a very specialized type of transformer. In general, we don't get that system unless it's a three-phase Y. Okay, so since we do have a three-phase Y, we now know that first of all, for our transformer overcurrent protection, we want to be in 430.3. I'm sorry, let me try that again. That would be for, go away, 50, try it again, 450.3. And when we talk overcurrent protection, I'm sorry, for less than 1,000 volts, that's 450.3B, 450.3A, over 1,000 volts, 450.3B, less than 1,000 volts. So, okay, now 450.3B sends us to table 450.3B. Now we know that since we have a neutral, the secondary conductors are not considered by the primary, protected by the primary overcurrent protection, so we need primary and secondary protection. Now we also know that we're going to have to go look at our 240.21C, 240.21C tap rules, right, to not have secondary protection, right, to fall within our secondary conductor tap rules, but we're not worried about that right now. The question is, hey, what size overcurrent protection do you need on your primary? Okay, well, the first things first, we have to decide, do we have current of 9 amps or more? We know we need primary and secondary protection. We know we're going to be in row 2 here. So, okay, is it 9 amps or more? I don't know. I'm going to assume probably so. Like I said, got a big transformer. Well, we know that P equals, I'm sorry, let's try this again. What we know is that I equals P over E. All right, Ohm's law, okay? In this case, that's given to us in kVA. P, our power, is given to us in kVA. So we get 112.5 kVA, okay? Now, we don't need this to be in kVA. We need this to be in just volt amps. So we're going to have to multiply that by 1,000, okay? And we're going to divide that by our voltage, our primary voltage, which is 480. But since this is three-phase, what do we got to do? Multiply that by 1.732, or the square root of 3, which equals 1.732. So here's our formula. So we punch that into our calculator, and that gives us 135.3 amps. Okay, so now we know the rating of the primary side of our transformer is 135.3. That is certainly more than 9. So second row, first column here for primary protection, tells us, hey, you could size this dude all the way up to 250%. So, okay, our primary protection overcurrent device has to be less than or equal to, okay, it can't exceed, this is the maximum setting of, in this case, our current, our primary current rating, 135.3 times 250%, or 2.5. So we go ahead and plug that into our calculator. and we get 338.3 amps. That would be the largest overcurrent protection, breaker or fuse, that we could have protecting the primary of our transformer. Now you guys see a problem with that? Why don't you go to your local supply house and say, hey, I'm needing a 338 amp breaker. And they're going to say, well, good luck, right? So we can't exceed that, since no note 1, right? We can't exceed that. So we go cruise over to table 240.6, and we find the next highest size breaker or fuse that's less than 338. Well, 300 is a standard size. 350 is a standard size. Well, 350 is larger than 338. So our green ink correct answer would be 300, right? That's the largest overcurrent device that we can protect this breaker with. Protect this transformer with. That's not over 338 amps.